Good afternoon, good evening, good morning. Not quite sure what day it is now. All right, so I'm John. This is Andrew. We're engineers at Shopmonkey. We've been in the business a while. We were counting years the other day, and we're like, oh man, it's that part of the career time where you're like, dang it. Now it's not like I'm. There's a lot of numbers on there. So yeah, we both have an affliction for data systems. Oh, get in the picture. So and making things run well. It's kind of we've both been around the startup circuit. Andrew's been at Meta. I've done a bunch of stuff in oil and gas. So a lot of weird data, a lot of big data, a lot of nasty data. So that's what we're here to talk about today. So Shopmonkey, who are we? What do we do? So y'all have been to Auto Shop. You've all got text messages, paid your bills. That's what we do. So there's a few players in the space. We're one of them. We were founded in 2017 in California. And we've scaled all the way up to 7,000 auto shops across the country. So as happens with startups, at a certain point, your initial architecture isn't your scaling architectures. And at this point, it hit really, really quick. So we hit a scaling cliff. So we began a replatform in 2022, and it was a complete, ground up build of the system. So a lot of blue sky stuff, like what are we looking for, in the next future of Shopmonkey? What do you want to do? So to put this kind of into scope, so our 7,000 shops, it's part of a total addressable market of around 350,000 shops. So there's a ton of shops. So how do you build for that and still be able to pay your bills? So, so our kind of our architecture right now is we're on GCP. We're trying to run multi-region. So with that, we went to Cockroach. Which is great for the active replication. We're running clusters across all 3 regions in the US. We use NAT as our messaging bus. It's not the most popular one, but it's lightweight, simple. Kind of the overall architecture, we're an event-driven modular monolith. So most of our services are TypeScript. There's a few hardcore, infrastructure ones that are written in Go. And then as TypeScript doesn't perform, we port them over to Go. So this all came about, as we're building the system and starting to congeal. The initial hypothesis was, hey, can we write reports against ClickHouse? How does it do for analytical data? Turns out about as well as you think, so we added ClickHouse to the stack.
We started against Cockroach.
We started against Cockroach. Yeah, oops, yeah. Against Cockroach.
That went about as well as you think about.
Yeah, distributed SQL database, large analytic queries, yeah. Yep. Wait a while and watch the CPU max out, so good to go. So there are 2 primary use cases for ClickHouse in our replatform. So one is reporting, like Cockroach does things really well, and OLTP workloads, great. Analytical, they're like, don't do that here. They'll tell you that. And then kind of analytics. So one of the other things going into this replatform was, can we get away without re-upping on New Relic? New Relic's awesome, right? But it also costs as much as an engineer at a certain point, and then it scales like that. So, what if we could build into the system? Can we get enough telemetry between Prometheus and then some basically row-level analytics that you actually want to write a SQL query against? See what that looks like. So this thing on the right, that's kind of a picture of our high-level picture of our network topology. We kind of we use Google's load balancer, their global ingress. And then we route to 3 regions, depending on where you are located. The Google does some voodoo magic with that. And then we try to co-locate the shop data in the region of the Cockroach database, because auto shops don't move, right? So okay, cool, you're in US Central, your shop's in Austin, great. We're going to route you to the US Central service region and try to minimize the latency there. So kind of the analytics architecture we've got. And I'm starting here because this is kind of the easy one. This is the clickstream data. It's kind of like ClickHouse bread and butter. So kind of the initial thing kind of as that data flows through the system, right? We've got API requests. We go through our gateway, right? And then that forwards to a pod. So we instrumented the gateway tier. So every request that comes through the gateway, we pump an event out to NATS. Right, so NATS is the messaging bus, so we're just have a whole bunch of messages out there. So what we do with this is we sync the NATS data into ClickHouse. Andrew's going to talk about that. But the first implementation we did was we used kind of out of the box async insert for the analytics data. Like, cool, I got a message, make an async insert call to ClickHouse. Great, fire and forget. Well, that worked pretty well until it didn't. So, and then for the CDC events that we do, everything come out of Cockroach. We were doing sync inserts, again, 1 per row, which it sounds simple, but then you're trying to do tens of thousands per second or per minute, like it just takes a while. And then ClickHouse starts to blow up and we're on the phone with Sri and we're like, what happened? And he's like, what are you doing this for? Like, this is not how we're supposed to do it. You're blowing out your file space. So then we kind of retooled that whole system. We're like, great, we've got data coming into Stream. We have everything instrumented. We have it funneled through a message bus. Now, how do we get it into ClickHouse fast? So the other piece to that too. So like once we got it into ClickHouse, this is kind of the this is our internal ops dashboard. This is something that we built kind of internally in our free time. I built, yeah. Build it more for me because I got tired of people like, why is this broken? I'm like, well, go here and this is why it's broken. Like, I don't understand this error. I'm like, well, go find it in the code. Like, that's where it's broken. So there's no New Relic license. This is just basic ClickHouse data. And this thing's running actually against a fact table. There is no materialized view or anything. So it's a really, really nasty query. I'm like, this feels so gross, but look what I can do. And it comes back fast enough. So it's pretty fun. And Andrew's going to go through how we made it faster.
All right. So just, first of all, thank you for listening to me talk. Real quick, just a little note about the title. Said tens of thousands a minute. That is not impressive. I get that. That is only what I've observed. I am very confident this will scale much, much more than that. But I didn't want to oversell it and lie to all you fine folks. So that's why I put tens of thousands. Cool. So how do we get all of our data into ClickHouse? This is sort of a little diagram of our basic architecture. Jon talked a little bit about it from a much higher point of view. This is down a little bit more at the component level. But basically, we have a CDC stream coming off of our Cockroach instance. We aggregated it all up with Nats. And mostly what I'm going to be talking about is the aggregator service, as well as what we do in ClickHouse. Originally, my talk was going to be about that aggregator service. As I sat down to write the presentation, I realized it is very boring because our aggregator service is really just a buffer and a flusher. It's a Go channel that listens off of our Nats thing and then just publishes it out with async insert. There you go, talk done. So I decided to talk a little bit more about what else happens in ClickHouse, because I figured you guys would probably be interested in that part, seeing as how you're all ClickHouse users. So what happens? How do we ingest all this data into ClickHouse, and then what do we do with it? Great question. So the first thing we do, like I said, right, we just have a buffer little component, creates a consumer in Nats. It reads in our messages. It holds them in memory until it flushes them. It flushes it out using async insert. Every 2 seconds or 10,000 records. We're able to get through millions of records at a time, not at a time, in a very, very short time frame. We observed that this morning. We were a little backed up. We were able to flush them out into ClickHouse pretty quickly. So maybe I should have just changed the title of this presentation. Okay, so once they're in ClickHouse, then what happens? So we write them into this little depot db change fact table. Db change being just, database changes. This table's weird. It literally has every single database record change that happens in our system, regardless of the table. So it's kind of, I don't know, unstructured, I guess you would say. But every record has what table it's from, right? So what we're able to do is we have a materialized view. I used email as the example on all of these, but we literally have a copy for every single one of our tables. So we have a materialized view that sits on top of our fact table. It has a little where clause that says where table equals email. And we have one of those for every other table. Right, so we aggregated up into a materialized view, so that way now we have a materialized view per table in our transactional database. Next thing that happens, we have a replacing merge tree that reads from the materialized view to create just like a little fact table for that individual table. We use this in our reports. We hit this in our reports. This is kind of like the main source of truth, I guess you would say, in our warehouse. So now everything's in this fact table. We're able to hit it from our reporting engine in our application. But what we notice is joins are kind of slow. I'm not sure if you guys have noticed this in ClickHouse, which through no fault of ClickHouse, don't get me wrong, this is like trying to use a screwdriver as a hammer, which I do every time I need a hammer. So anyway, joins are kind of slow. So how do we speed up joins? What we found is actually using dictionaries is really, really cool. I don't know if you guys have used ClickHouse dictionaries at all. Highly, highly recommended, especially for dimensional data. That's pretty much mostly where we use it. So we read out of our fact table into another little view and then into a dictionary for our dimensional data. So we create like a little weird mini star schema, I guess you would say, for each of our tables that we have in our transactional database, and then we hit them with reports from our front end. So yeah. Now, one of the other things that I did want to sort of talk about for a second is how we deduplicate data, right? I know, I'm sure this is probably not a topic that most of you guys are unfamiliar with. Deduping data is something we all do in databases. So our DB change fact table is just append only, right? Inserts, updates, deletes, they all go in there, and then we have to sort of figure out what to do with them in ClickHouse, specifically in our materialized view, and then downstream from there. We kind of have to figure out what we're going to do with them, and a lot of that actually is taken care of by the materialized view definition. That looks at the operation that was performed on the data and figures out what to do with that information, right? If it's a delete, we're going to get rid of the record, or just ignore the record, I guess. If it's an update, we're going to use this set of the CDC data. Yeah, so that's there's a couple different ways that we can dedupe our data. I don't know if you guys are familiar with these, in which case, tell me to shut up. But from the fact table, right, we use the settings final one sometimes, right, from this email fact here, right? We also have in the dictionary and in this view here, right? This view and the dictionary, they achieve their deduping just through the deleted flag, and because it's a replacing merge tree, right? It just kind of does that deduplication as a nature of how we set up the view. So yeah, that was about 15 minutes. So I want to leave some time for questions. This is a really quick, really high level overview, but more questions?